For the fifth problem, we are given some numbers. The interval is 0 is less than or equal to theta, and theta is less than 2 pi, like we've been given before. Tangent equals to 4/3, and pi is less than theta 3 pi over 2. We have to find the exact values of sine 2 theta, b cosine 2 theta, c sine theta over 2, and d, which is cosine theta over 2. Now, before we start, we already know that tangent is opposite over adjacent because of SOHCAHTOA. So let's find c. To do that, we take 4, we square it, plus 3 squared equals c squared. So this is 16 plus 9 equals c squared. That leaves you with 25, square root both sides. C is equal to 5. So this helps us out because we know that we now know our sine equals to, opposite over hypotenuse. So our opposites is 4 and our hypotenuse is 5. Cosine equals to adjacent over hypotenuse. The adjacent is 3/5, and tangent is given, which is 4/3. So for the first part, we're going to look at the formula, the double angle identity formula. When you look up sine 2 theta, you get sine 2 theta equals to 2 sine theta cosine theta. This is where you basically plug in what you have. You already know sine, you already know cosine. So you do 2 times 4/5 and 3/5. And then you end up with 24/25. So that's the answer for part A. We're going to erase this because I don't have enough room on the board. I'm sorry. And for part B, we have cosine 2 theta. We're basically doing the same thing. We're going to look at the double angle identities, and we're going to find the one for cosine. This is listed as cosine 2 theta equals to cosine squared theta sine squared theta. We plug in the numbers we have. We already know cosine is 3/5, and we already know that sine is 4/5. So 3/5 squared minus cosine. Cosine is 3/5. So 3/5 squared minus 4/5 squared, which is sine. This leaves us with 9/25 minus 16/25 equals -7/25 for answer B. We're going to erase it because, yes. For part C, it's a little different. We can't use the double angle identity. For part C, it equals to sine theta over 2. We have to use the half angle identity. So when you look this up, this equals to 1 minus cosine theta over 2, but square root it. After we plug in the numbers that we have sine theta over 2 equals to plus or minus 1 minus 3 over 5 over 2. We take the numerator, take it out, we solve for it. 1 minus 3 over 5 equals 2 over 5. Then we bring that back in, we take this out. So now we're left with 2 over 5 divided by 2. To make it easier, we're going to do 2 over 5 times 1/2, which is the reciprocal of 2 over 1. This leaves us with square root 1 over 5. But we need to rationalize the denominator. So we take the square root of 5 on top and bottom. This leaves us with plus or minus square root of 5 over 5, because square root of 5 times square root of 5 equals square root of 25, which is equal to 5. So that's part C. Try and make it a little clearer. Sorry. Okay, for part D, we're going to use the half angle identity again. I'm just going to plug in numbers to save some time. So D equals angle over 2 equals plus or minus 1 plus 3/5 divided by 2. 1 plus 3/5 equals a over 5. A over 5 divided by 2 times the reciprocal again times 1/2 equals a over 10. That reduces down to a square root 4 over 5. Square root 4 equals to 2. We have to rationalize the denominator again. So square root 5, square root 5. And then this leaves us with the final product of 2 square root 5 over 5 as the answer. So I'm going to put everything into place now. Let me fix this on the bottom. Tangent is equal to 4 over 5. So for part A, we get 24 over 25. For part B, we get square root of 5 over 5. I'm going to make it a little more clear. Square root 5 over 5. For part C, we get... No, I'm sorry. I made a mistake. For part B, we get negative 7 over 25. For part C, we get square root of 5 over 5. And for part D, we get 2 square root of 5 over 5. So those are our 4 answers.